Hi everyone, really quick video here. So I'm going to just fly through some key topics that are worthwhile making sure that you know how to do these fundamental skills in preparation for your paper 1. So let's jump straight in. First of all, fractions, you need to know how to add, subtract, multiply and divide with fractions. So if we've got something like this, where it's a mixed number, look at multiplying the big number by the bottom number and adding the top first. That's what I've done in that blue section there. So 3 times 2 is 6 plus 1 is 7. And then remember, you must make your bottoms the same. So if you can see here, what I've done, times that by 5, times that by 2. Whatever you do to the bottom, you got to the top. And then add the top, and you leave the bottom. Remember, do not add the bottom. So it ends up being 57 over 10. And then it's a good habit just to get used to. That would end up being 5 and 7 over 10 because 10 goes into 57 5 times with 7 left over. If you are subtracting, it's exactly the same process. So I'd still do the 5 times the 2 to get my 10 plus 1 gives me my 11. And then 2 times 5 is 10 plus 1 is 11. So you end up with 11 over 2, 11 over 5. Make your bottoms the same. So times by 5, times by 2. And then again, same here. 55 minus 22 gives you 33. And that is 3 with 3 over 10. And then the next one, if we're talking about what we do, is times in. So big number times the bottom plus the top gives me my 11 over 3 and my 18 over 5 there. And then all you do here is top times top and bottom times bottom. Nice and easy. 11 times 18, which is 198. 3 times 5 is 15. And then again, simplify from there. We end up going 15 goes into that 13 times with 3 left over. Now just be careful in your exams. This fraction here, always check, does it simplify? Divide by 3, divide by 3. And then the last one for fractions, you need to know how to divide. So big number times the bottom plus the top gives me that. Big number times the bottom plus the top gives me that. And now with this, remember, keep the first one the same. So that's my keep. Flip this one upside down, change the sign to a times, and then I follow the same rules as I did here. So 13 times 7 and 5 times 8. Okay, so moving on to the next topic now, we're looking at percentages. So just make sure you know how to find your key one. So in this instance here, what we're talking about is being able to find 10%, 5%. So on a non-calculator paper, we'd probably be looking at 15%, 10%, 5%, 25%, those kind of numbers. So if I say find 15% of 180, first of all, to find 10%, you divide by 10. So 180 divided by 10 is 18. And then what I need to do here is once I've got that value, divide it by 2 to get my 5%, which gives me 9. And then add those two together to get me 15. So I add these two together here. Now, so 5%, divide by 10 first of all to get you 10%. And then you divide that number by 2 because to get this to 5%, I divide by 2. If it was 25%, a couple of things you could do. You could divide by 4 because 25 goes into 100 4 times. Or you could do your 10% by dividing by 10, times it by 2 to get 20%, and then find your 5% and add it on as well. If you need more information on that, then watch the video on percentages because it will help you, really common. Now, you could just be asked to find 15%, especially those who want foundation, but it could also say increase it by that amount. So if it says increase by 15%, so follow the same process here, find your 10%, find your 5%, add them together to get 27, and then because it says increase, you add it to your original number of 180. Just make sure you read the question really carefully what it's asking you to do, so that would be 207 there, but it could also say to you to decrease it by a certain amount. So if it said decrease by 15%, I find my 10%, find my 5%, which is 27, and then I subtract it. Okay, so make sure you're solid on your percentages, 10%, 5%, 25%, and just remembering that the reason we divide by 10 for 10% is because 10 goes into 100 10 times. Okay, number 3, fractions of an amount. So really simple, this one. If you want to find a fifth of a number, for example, you divide by the bottom times by the top. So 65 divided by 5 is 13, and then times that number by the numerator. In this case, the numerator is 1, so it's just 13 times 1, which is 13. So 1/5 of 65 is 13. Could be a little bit more complicated. It could be something like 2/7. So same process. If you remember this red phrase here, divide by the bottom. So 49 divided by 7 is 7, and then 7 times 2 gives me 14. So divide by the bottom times by the top is the key thing for you to remember. Number 4, so one of these things that a lot of people get messed up with, a prime factor tree is exactly what this is asking for. Express 360 as a product of its primes basically means do this, which is where you get your numbers, what multiplies to 360. It doesn't have to be 36 and 10, so you could have broken it down to 180 and 2, which I know a lot of people like to do. But in this case, if it ends with a 0, you know you can divide by 10. So once you've got your prime factors here, write it out like this. So 2 times 2 times 2 times 3 times 3 times 5, which gives me that. And then get used to doing this. Make sure you put it as a power. Just in case it asks you to express it in index form, you have to make sure you do that. Do not put a plus sign between these, and do not put a comma. Make sure it is a times, because actually if I work this out, 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, And then effectively, when I do 24 times 3 and then times that by 5, I'll get 360 as well. So make sure you put a time sign. Now that leads you into highest common factor and lowest common multiple. So if you're asked to find the highest common factor and lowest common multiple of two numbers, then what you do is you work out the prime factor tree for both of them. So we've already done 360, which we know is this. And 150 I've broken down here gives me this. And then do a Venn diagram. And then what you're looking for is which numbers match up. Well, there's a 2 in both, so these two merge together to make that 2. There's a 3 in both, so these two 3s merge together to make that one. And then there's a 5 in both, so the 5 goes in the middle. So once you've done that, so there's my 2 that matches up, there's my 3 that matches up, and there's my 5 that matches up. Whatever's left goes into each Venn diagram. So 2, 2, and 3 are in the 360, and the 5 is left over there. Then from there, you need to remember this. The highest common factor is found by multiplying this middle section. So 2 times 3 times 5, 2 times 3 is 6, 6 times 5 is 30. So the highest common factor here is 30. So remember that middle section is highest common factor. And lowest common multiple is just from multiplying all of these together. So 2 times 2 times 3 times 2 times 3 times 5 times 5. When you do that, you get 1800 in this case. Okay. Just remember the middle section there is your highest common factor, and all of it together is your lowest common multiple. Okay, number 5, just quick recap on laws of indices. When we are multiplying, so a times a times a gives me a to the power of 3. It's not 3a. A plus A would be 3a. So just be aware of that, especially those of you on foundation. Now, when laws of indices we're multiplying, a to the power of 3 times a to the power of 5, we add the indices together, remember? And if we have a number in front of it, the first thing to do is to do the numbers first. So 2 times 5 is 10, and then you add your indices afterwards. If you're dividing, so it could be written like this, where it's a to the power of 7 divided by a to the power of 3. It could also be written like this, a to the power of 7 divided by a to the power of 3. So either one of those means the same thing. You subtract the indices. So in this case, 7 minus 3 gives me 4. 8 divided by 2 here gives me 4, so you deal with the numbers first, and then a to the power of 10 and a to the power of 4, I subtract those to get a to the power of 6. And then the last one here, just to be aware of, is if it's in brackets, so 3a squared to the power of 3, for example. Now this means 3a squared times 3a squared times 3a squared. It's best to write it out 3 times because it's a power of 3. What you now do is you follow the same rules as what we did back here. So we're doing 3 times 3, which is 9. 9 times 3 is 27, which is how I've got that 27 there. And then I add my indices here of 2, 2, and 2 to get a to the power of 6, okay? So just remember your laws of indices. Those of you on higher, you will need to remember your fractional laws of indices as well, and your negative laws of indices, so make sure you're solid on those. Number 6, rounding, really simple here. Just remember when we round into decimal places, so 2 decimal places here is the 4. Draw a line after the 4. What does a 6 do to the 4? It pushes it up to a 5, so your answer is 8.75. Significant figures. So here, the first significant figure is actually the 6. So a significant figure is the first number that's not 0. So 1, 2, 3, and then the 7 pushes the 4 up to a 5. So make sure you know the difference between a decimal place and a significant figure. And in this case, when it's a whole number and not a decimal, we're still doing the same thing, whereas the 8, 2, and the 5 is the third significant figure, but because there's no decimals, this 7 pushes this 5 up to a 6, but these numbers have to turn now to 0, so that number becomes 82,600. Okay, so make sure you're happy with the difference between those. Number 6, estimating, so it kind of links to what we've just done there. If we're talking about a plane traveling 620 miles in 3 hours and 12 minutes, we're looking at rounding the numbers first of all. This key word here, estimate, you need to make sure you look for in your exam, because if you work it out exactly, perfectly, but you don't round, you won't get any marks. So 620, the first thing I would do is round that to 600, and in 3 hours and 12 minutes, I'd call 3 hours. Make sure you know your speed, distance, time. Okay, so your formula triangle there, and I'm being asked to find the speed, and speed is equal to distance divided by time here. Distance in this case I've done as 600 miles, and the time is 3 hours, so just 600 divided by 3. So it could be in context, or it could also look something like this as well. Now, in this instance, same concept. This wiggly line that we've got here means is approximately, so that purple bit there. What we need to make sure we do is we round 6.2 to 6, 7.4 to 7. You're rounding to one significant figure here. So the 6 stays the same because of the 2, the 7 stays the same because of the 4, and the denominator here, 0.2, will round to, 0.21 will round to 0.2 because the 1 keeps it the same. Then you work out 6 times 7, which is 42, and then divide by 0.2. What you're basically trying to work out here is how many times do I have to multiply 0.2 to get it to 1. So I times that by 5 to get it to 1. Therefore, I have to times the top by 5 as well, which gives me 210 over 1. Okay, so that's your estimating. 7, really simple, collecting like terms. Just make sure you put your circle around the values, and if there is a negative in front of it, remember that's a minus 6. So you're saying 2 minus 6, which gives me minus 4. and then 5b plus 7b all becomes positive. They can't go together. One's an A, one's a B. Just be aware of this instance here. If you've got indices involved, this is basically saying how many a to the power of 3s do I have? Well, I've got 5a to the power of 3 there, 7a to the power of 3 there. So if I add those together, I get 12a to the power of 3. Next one, expanding brackets. So look at it as two separate questions, the blue bit and the red bit. So 12 times x gives me 12x, 12 times 5 gives me 60. Work out the blue bit, minus 7 times x is minus 7x, and then minus 7 times minus 2 is positive 14, and then go back to what we just did, collect your like term. So then moving on from this, what you need to be aware of is double brackets. So I like to call this the moon method. So what we're looking at doing is the x times the x to get x squared, x times minus 8, minus 8x, 2 times x, 2x, 2 times minus 8, minus 16. Just remember, collect your like terms here. These are both x's. And just be careful of the signs. This is negative 8x plus 2x, which gives me minus 6x. Okay. Okay, moving on to the next one. So just solving equations comes up quite a lot in multiple different ways. It could just be as basic as the question you've got here, but it could be you have to form the equation yourself and solve it. But just remember, if a question says solve, it means find the value of x. So in this case, we're going to move the minus 5, and when you're moving that over the equal sign, remember it changes sign. So if it's a minus 5 there, it becomes a plus 5. Anything that is in front of the x actually means 6 times x. So when I move that over, it becomes a divide by 6. Therefore, x is equal to 8, and that makes sense. If I was to put 8 in here, 6 times 8 is 48, minus 5 gives me 43. The next one, a bit different, but the concept is still the same. Now, in this one, the reason we moved the minus 5 first was because it was not attached to the x. Same thing here. This plus 9 is not attached to this x, so we move this one first. Circle it, move it over, and it's a plus 9 now, so when we move it over, it becomes a minus 9. X over 3 means x divided by 3, so when you take this 3 over, becomes a times by 3, and then 4 times by 3 gives you 12. Double check it. 12 divided by 3 is 4. 4 plus 9 gives you 13. So just remember your rules of solving. When you're moving something over an equal sign, it changes sign. If you have x's on both sides of the equation, move the smaller x. Okay. Number 10, standard form, really common, could come up in multiple different ways, but we've got the basics here of converting into standard form. So currently the decimal is there. The decimal has to become 8.93 because this first number must be between 1 and 10. And in order for me to get the decimal to that point there, I've had to move it 1, 2, 3, 4, 5, 6. So I've moved it 6 spaces, but I've actually times it by 10 6 times. Because this is a really small number, it becomes a negative power. Okay, so just remember that. Really small number because it's 0.000000893. Make it a negative power. And then in the second example here, it's very different. The decimal is currently at the end because it's 874 million. Same thing, decimal has to go between 1 and 10. So it's 8.74. My decimal is currently going 1, 2, 3, 4, 5, 6, 7, 8 spaces to the power of 8. In this case, it's a positive power. Really big number, positive power. Really small number, negative power. Now, you could very well convert this into a normal number by doing 4 times 10 to the power of 3. And actually, you could write that as 4,000, right? And then you could do 3 times 10 to the power of 5 and work that out and then do your sum that way. But a quicker way of doing it is by doing this. So you do your 4 times by 3 first of all, which gives you 12. 10 to the power of 3, 10 to the power of 5. You add these indices when we're looking at multiplying with indices, like we spoke about previously. So 3 plus 5 gives you 8. So 12 times 10 to the power of 8. But the problem here is that 12 is not in standard form because this has to be less than 10. So the decimal is currently here. So shortcut, little trick, if you move this down 1, you move this power up 1. So it becomes 1.2 to the power of, times 10 to the power of 9. And then the last example, same concept, but with division. So 8 divided by your 2 that you've got, 8 divided by 2 is 4. And then now when we're subtracting with indices, when we're dividing with indices, we subtract. So 10 to the power of 8, it's 8 minus 6. So be really careful there. If there's a double negative, that actually becomes plus. Okay, so that's why it's 4 times 10 to the power of 14. Okay, so that's 10 key things we've gone through. The next one here is just about multiplying and dividing with decimals. So column method, 34.2 times 3.7. What you do is get rid of the decimals, so it actually becomes 342 times 37. Work it out as normally you would. 7 times 2 is 14, so 4 carry my 1. 7 times 4 is 28, plus my 1 is 29, so 9 carry my 2. 7 times 3 is 21, plus 2, 23. So that red bit is the first bit. Now I'm working with a 3, put my placeholder of a 0, because I'm actually working with a 30 there, not just a 3. 3 times 2 is 6, 3 times 4 is 12, so I put my 2, carry my 1 up here, 3 times 3 is 9, plus your 1 makes 10. So that's the purple section. Add your numbers together, so 4, 15, carry my 1, 2, 3, and 1 makes 6, 2, and 1. So the digits I have are 1, 2, 6, 5, 4, but because what I've done in my sum here is I times this number by 10, and I times this number by 10. So there's 2 decimal places here, therefore there has to be 2 decimal places in my answer. So currently my decimal's there, I move it back 2 places, it becomes 126.54. Or if you want to actually think about what we've done, we've times by 10 there, we've times by 10 there, therefore I have to divide by 10 and divide by 10 again to get my final answer there. Now with division, a bit different. All you need to do is first of all make this number that you're dividing by, so there's 0.3, times that by 10 in this case to make it 3. You want to make that number you're dividing by a whole number. Could be you have to times by 10, could be you have to times by 100, but just whatever you do to that one, you then got to do to this one. So 67.8 actually becomes 678, and 0.3 becomes 3. 3 goes into 6 twice, 3 goes into 7 twice with 1 left over, and then 3 goes into now 18 6 times. So your answer is 226, and you do not change anything back there. Okay, the 67.8 divided by 0.3 is exactly the same as doing 678 divided by 3. Okay, remember when you're dividing with a number that's less than 1, in this case we are, it will make your answer bigger, so the answer will be bigger than that. Right, only on higher do you need to worry about this. So if you're doing foundation, don't worry about this next bit. So make sure you understand how to simplify surds. So root 8, you're looking at what square number goes into 8. So 4 times 2 is 8, and the square root of 4 is 2, so it becomes 2 root 2. When you're multiplying surds, you can just literally do 8 times 5 to get root 40. You could simplify it first, but this is a bit of an easier way to do it. 8 times 5 is root 40. What times by, what square number is going to 40? Well, 4 times 10, square root of 4 is 2, so it becomes 2 root 10. Then you've got your concept of rationalising here in the third bit. Make sure you're really solid on this. To rationalise 6 root 3, you times it by root 3 over root 3. So there's just one value at the bottom, that over itself. 6 times root 3 is 6 root 3, and then root 3 times root 3 would be root 9, which is 3. And then when you're dividing here, don't touch the surd, just do 6 divided by 3 to get 2. Okay. And in the last section here, what we're looking at is 2 values at the bottom, so 5 minus root 8. We actually now multiply, there's a lot going on here, but just follow me with the colours. This fraction here gets multiplied by 5 plus root 8, so it's the opposite of this, where it's a minus root 8 becomes a plus root 8 over 5 plus root 8. Then you do your mu method, 7 times 5, 35. 7 times plus root 8 is 7 root 8. Root 2 times 5 is 5 root 2, and then root 2 times root 8 is root 16. Same at the bottom, 5 times 5, 25. 5 times root 8 is plus 5 root 8. 5 times minus 8 is minus 5 root 8. And then minus root 8 times positive root 8 is actually just a negative 8 because it's root 64 and then becomes minus 8. Tidy up and collect your like terms. Root 16 becomes 4, so 35 plus 4 becomes 39. Then this root 8, as we did here, becomes 4 root 2. Now, if you've already got a number on the outside, when you square root it, I'm bringing the 2 out over here like we did. So square root of 4 is 2, and then you times it by the number that's there, so it's 7 times 2 is 14. 14 root 2 plus 5 root 2. The denominator, these two values cancel each other out, so therefore you don't have a surd at the bottom anymore. That's exactly what you're doing rationalising. 25 minus 8 is root 17. Collect your like terms at the top, 39 plus 19 root 2 over 17. If you need more information on that, go back and watch the video I've done on it. Again, for higher mainly, the first one here could be on foundation as well, but for higher mainly, solving quadratics, factorise it, add to 7 multiplied to 12 is plus 4 and plus 3. One bracket equals 0, other bracket equals 0, minus 4, minus 3. You could also use your quadratic formula. You could complete the square. Remember, if there's a value in front of the x squared, so if the coefficient in front of x squared is greater than 1, you do your 2 times your minus 35 to get minus 70. You're now looking at two numbers that multiply to minus 70 and add to 9. In this case, plus 14 and minus 5. Put your 2x in front. This is a shortcut and a cheat, remember? So 2x goes there, 2x goes there. One of these brackets will simplify, so that divides by 2. Therefore, I get x plus 7. 2x minus 5 stays as it is. And then I go through my process I've done here. X plus 7 equals 0, so it becomes minus 7. 2x minus 5 equals 0, so move the minus 5 over, it becomes plus 5. And then divide by 2. Okay, so make sure you know how to do that when the coefficient of x squared is greater than 1. If you don't have to solve it, it's in part of an algebraic fraction or something, just make sure that you divide one of them and you factorise it simply just as you would there. So the next part here is just a quick reminder on how you would complete the square and then use completing the square to solve as well. So it could come up in paper 1, but just a reminder, what you are looking at doing is taking your b value, this is your b value, half it, put it in brackets, square it, turn it negative, and then bring down your c value here. Tidy all this up, which gives you minus 9 minus 8 is minus 17. And then from here, this could be just what it asks you to do to complete the square. So it might ask you to put it in that format. If that is the case and asks you for a turning point, change this sign, it becomes minus 3, minus 17. If you're not sure on completing the square, watch the video I've done on that. But if it then asks you to solve it, take the minus 17 over, becomes a plus 17, get rid of the square root, by square rooting, and just remember when you square root a value here, it's plus or minus root 17, and then from there take the 3 over, so it's plus or minus root 17 minus 3. And then if you're asked to do that, just as a really quick one, in terms of when x squared is greater than 1, here's the way that I explain it, and I would do it. Factorise out the 3 first of all, so this therefore becomes x squared plus 3x minus 4, and then basically ignore all of this on the outside and just complete the square as you normally would, so half your b value, put it in brackets, square it, turn it negative, and bring down your c value. Tidy this up, which gives you minus 6.25, and then from here, what you're basically doing is you're saying, right, well, 3 multiplied by that gives me this, and 3 multiplied by the minus 6.25 to get minus 18.75. And then from there, you'd go to your solving process. So take the 18.75 over, but this time instead of square rooting next, you have to then divide by the 3. So you're kind of undoing what you've just done. And then positive or negative root of the 6.25, and then minus the 1.5. Okay, so that's a quick reminder of how to complete the square. And remember, you could also solve quadratics by using the quadratic formula. And the last thing for me to say is just good luck and try and put an answer down for every question. And I hope the paper all goes well for you.